you're seeing my screen, you see the limit as x approaches infinity of this rational function here.
Mhm.
There is a shortcut here, but the with some rules, but to do this correctly, you're supposed to identify the highest degree term.
So 4.
Yeah, the highest power, and you divide everything by that. So you're gonna the sort of the full way to do this is to divide the numerator by x to the fourth, and the denominator also by x to the fourth.
Okay.
Okay, so notice that you're going to have to remember your power rules here, but this becomes the limit, and I'll write this line a little neater. It becomes 4 over x minus 2 over x squared, and that's up here.
Yeah.
Plus 3 over x cubed minus 4 over x to the fourth, all over 1 minus 3 over x plus 2 over x squared minus 1 over x to the fourth.
Okay.
Now kind of off to the side here is this very important thing, which is the limit as x goes to plus or minus infinity 1 over x to the p for p greater than 1 always is 0. And all that means is if the exponent on the bottom is 1 or bigger, it goes to 0. So this is 0 for the 4.
Where do you get the 1 or bigger from?
P greater than 1. Is that what you're asking?
Yeah.
That's just a known thing. This was in your
But
textbook.
like where in this equation is p or x to the p?
Right here, this x to the 1.
Oh.
So it's like 4 times 0, because this is really 4 times 1 over x, minus 2 times 0, because it's 1 over x squared, plus 3 times 0, because it's 3 over 1 over x cubed times 1 over x cubed, minus 4 times 0. So some students don't even, they just write 0, 0, 0, 0.
Mhm.
But notice on the bottom you don't get that. You get 1 minus 3 times 0 plus 2 times 0 minus 0.
Okay.
This becomes 0 over 1, which is 0. Yeah.
Okay.
You wrote on your exam, which is the shortcut here, but it's like if this was free response, which I guess we won't be doing, but or we will be doing, but the degree of the numerator is less than the degree of the denominator, then it always goes to 0.
Oh, okay. Okay.
All right. So that's the shortcut. Here's one kind of like it.
What is this called?
Infinite limits.
Okay. Okay, so you do. So you divide the entire numerator by x to the third. Oh,
Yes.
okay. And then the denominator too. So that's squared. And then are you just, so then once you divide everything, the top and denominator, do you just move the denominator up and like subtract everything? Because
No,
it's like,
so like if you're to the step that I think you are, you have 4 minus 2 over x plus 3 over x squared minus 4 over x cubed.
yeah,
And then down here, 4 minus 3 over x plus 2 over x squared minus 1 over x cubed.
yep.
Now you use this thing that I mentioned up here in this cloud, the fact that if you have 1 over x, basically 1 over x to a power, they become 0. So you're and what some students is they actually put infinity down here, which isn't correct, but it's like it's reasonable to think that way. It's like 2 over infinity is 0, 3 over infinity squared is 0, 4 over infinity cubed is 0. So it's 4 minus 0 plus 0 minus 0 up top.
So it's 4/4, which is 1.
Yes.
Oh, it's like the same power as 1. So would they ever give you one where p is not greater than 1?
No,
Okay.
because you're always dividing by the highest degree power. It will always be.
So same power is 1, and if the numerator is greater than the denominator, it's 0, or was that backwards?
Well, let's just say there was a 7 here instead of a 4. It would be 7 over 4.
Oh, so they have to be the same.
It's the ratio. It's the ratio of this.
Oh, okay.
So like I like that you circled these, but you also needed to somehow like identify the leading coefficients.
Okay.
Like here's one I would give you. This is being difficult. It would be 5x to the third minus 2x squared plus 3x minus 8 over 9 plus 4x minus 5x squared minus 9x cubed. And we'd want the limit as x goes to infinity on this one.
Is there a trick if it's the numerator greater than the denominator?
They're actually the same because it's here and here. So the order doesn't matter.
Oh,
So the
so it's
short,
5 over -9.
yeah, yes.
But what if it was the
Let's say-
numerator greater than denominator? Yeah.
If in this case, actually, let me do this because I know you like to look at this stuff later. Let me change it down here. All right, so let's make this a 4 now. Because it's bigger, it goes to infinity.
Okay.
And the reason is when you divide everything by that, you end up getting the intermediate step here is you get 5 over 0, which leads to that.
Okay.
Okay, another limit question for you, number 6 here. You always try when you're doing a limit at a point, you always try to put the value in. But the problem is here, when you put 0 in for, or I'm sorry, -5 in for x, the bottom becomes 0. And I think the top does as well. So like what I'm trying to say is if you put -5 in the top and -5 in the bottom,
Mhm.
you get 25. Yeah, you get 0 over 0, which is bad because you can't divide by 0. Okay, so you want to do something, and the something here is you want to factor
Okay.
the
So
top and the bottom.
that would be x minus or +5, x minus 1 or +1, x -5, x +5. The x +5s cancel.
Okay, and then you go back to trying that again. Like, does it work? X plus 1 over x minus 5.
So then that's -4 over -10, so 4/10.
Yeah.
Oh, 2, yeah.
All right, so try this one on your own.
So when they give you a number, never just like plug it in.
Well, you can try, you should try. Like sometimes it does work, but you should be prepared that it won't help you.
Okay.
So give that one a try, please.
-2.
Yes, that's correct. You should have gotten this down to x plus 5 over x minus 1. Is
Yeah.
that right? And then you got
And then you plug
4
it in.
over.
Yep.
Okay, very good. All right. Do you recall if the instructor said anything about the definition of the derivative being included or not included on the final?
Definition. Like, what do you mean by that? Like, find the derivative of that?
Yeah, but using what's called the definition derivative, which is the limit as h goes to 0, f of x plus h minus f of x all over h.
I can ask him. I mean, it's multiple choice, so
I would think not
yeah.
based on that, but it's a fair question to ask because
We
it,
haven't, we haven't technically started reviewing yet. Like, we're reviewing tomorrow and Thursday. So I'll ask him tomorrow.
okay, great.
Oh, and the only other thing that will be on this that there's not, like, in the test that I sent over is Hopital's rule.
Okay, great. All right, let's look at this this piecewise function. And we can actually make this one a little bit more sophisticated because you know derivatives now. So like the first thing I want us to do together is look at this from a from the like non-calculus point of view, which is the only thing you can look at is continuity.
Okay.
And like at each of these breakpoints at 0, at 1, and at 2. And I guess I'm asking, I'm really asking three things here. Is it continuous x equals 0, and then B is x equals 1, and then C is
-1.
-1's the left bound, so you wouldn't
Okay.
touch that. But so do you know how to check this?
Plug it in, right?
Into each one?
Yeah.
Like for 0, you want to try and both of these here.
Isn't it? So it's just where 0 is like in the domain.
Say that again.
It's just where 0 is like in the interval.
So you want to check it in both of these. Like, okay, let me try to help here with A. What I'm asking is 0 squared minus 1 equal to 2 times 0.
No.
No, so it's not continuous there.
Okay, yeah, I remember doing this. So then it's 1 times 2. No, for x equals 1.
This one's a little bit different because it actually gives you the value at 1. But you have to check what's going on with you have to check this 2 times 1 equal to 1 equal to -2 times 2 plus 4.
But isn't 1 not defined at -2x plus 4?
So here's what we're actually doing. Now I guess let's go to the calculus. At 1, for something to be continuous, here's what has to happen. Here's what has to be okay. The limit as x approaches 0 from the left has to equal the limit as x approaches 0 from the right has to equal f of 0.
Okay.
So let's like tackle that for this first one. So for this first one, the limit as x approaches 0 from the left is putting 0 into this thing.
Yeah.
0 from the right is this next one, 2 times 0. F of 0, you have to use the one where it's defined, which is this first one. And they have to all equal the same value. If they don't, if anyone is different, like no good, not continuous.
Okay.
So do you agree here? Like it's still the same answer, still no.
Yeah.
Okay, now let's do it for the go ahead.
X equals 1 is not continuous. Then.
Yeah, but let's do the same thing so you can see it all the way through. I'm going to just snip this this part in. So what you're doing is the limit as x approaches 1 from the left, does that equal the limit as x approaches 1 from the right? Does that equal f of 1? So 1 from the left is 2 times 1. From the right is minus 2 times 1 plus 4. And then f of 1, you actually use this middle value.
Okay.
So is 2 equal to 2? Yes, but it doesn't equal 1.
Yeah, so no.
So no, this one's not continuous. But does the limit exist? Does the limit exist?
So that's where you just look at the left and right?
Yes.
So yeah.
Yes. All right, let's look at the last one and do the same analysis. So we want to do the limit as x approaches 2 from the left, limit as x approaches 2 from the right, f of 2.
Okay. So negative 2 times 2 plus 4. That's negative 4 plus 0. Then so yeah, it does exist.
So this one is minus 2 times 2 plus 4 equals 0 equals minus 2 times 2 plus 4. And this one is good. It's 0 equals 0 equals 0.
Mm-hmm.
So yes, it's continuous. And then does the limit exist? Yeah. So there's this interesting thing. If the limit exists, I'm sorry, if it's continuous, then the limit exists always.
But if the limit exists, it doesn't have to be continuous.
That's right.
Okay.
All right. So
what's the other one? Differentiable comes from the derivative.
Yeah. So you can do, so if it's differentiable, this is the good way, then it's continuous, then the limit exists. Okay. Always. But the other way is only sometimes true.
Right. Okay.
Sorry, I'm looking at, is the same. Okay, so this one's easier because it's got less going on. So let's, like, I'd like you to do the same quick analysis. Like, tell me what's happening at 3, like as much as you can. Is it different? Is it continuous? Is it, does the limit exist? Tell me. Go ahead and try this one on your own, please.
Continuous and the limit exists.
So is 3 plus 2 equal to 4 times 3 minus 7 equal to, now you have to evaluate it at the point 3 plus 2, and the answer is yes, like you just said.
Mm-hmm.
Okay, now we actually can do a bit more because you know a bit more calculus. So we'll do it for this one. What is f prime of x? What is the derivative of each of these?
1 and 4.
So are these the same? It's
No,
no,
not differentiable.
it's not differentiable. But let's just say, let's just say, yeah, I can't do that. I can't make that work. So I was trying to find something that would work there, but it doesn't. So we'll do that there. All right. Okay, so here is maybe a question to try. This one's different. Like we don't necessarily have to look at this through the lens of like chapter 2. And you said yes or no to this L'Hopital's rule.
Yeah, that will. I think he said it would just be on the multiple choice. I remember.
Okay, so this is a great example of that. So when you put 0 into this, and I'd like you to do that on your own, tell me what the top and bottom becomes, please.
So sine of 0. Sine of 0 is 1, right?
Sine of 0 is 0. So you're looking at the unit circle. You're looking right there. What's the y value right there?
Oh yeah, it's 1 comma 0. That's fine. Okay, and then so it's 0 over e to the 0. Is e to the 0 1?
E to the 0 is 1.
Okay, 1 minus 1, so it's 0 over 0.
Okay, so this is indeterminate form.
Yeah.
So this is where you use the L'Hopital's rule. So whenever you get this form, which is one of the indeterminate forms, you want to take the derivative of the top and the bottom separately. It is not quotient rule. It's like you need to take the derivative of sine 3x.
Okay.
So it's cosine 3x times 3. And the derivative of e to the x is?
E to the x.
Okay. And minus 1 goes away. And then you try this again. So you put 0 back in again and see what you come up with.
Cosine of 3, right?
Cosine of 0, because x is 0.
Oh, you're putting in 0. Okay. Cosine of 0. So that's 1 times 3. And that's 3 over e to the 0 is 1. So 3.
Yes. All right. So here is another kind of variation on that. Actually, no, you want one like that. I'm sorry. Let me get that. So be right back here. Let me go find.
Wait, so is what I just did L'Hopital's rule or?
Yes.
Okay.
But it's see, like you know this from before. I mean, math classes, they kind of hide things from you.
Yeah.
You would, if you knew this, you would use it. No. So will you give this one a try? I know it's really similar to the last one, but could you give that one a try, please?
So
Or I can make one up that's slightly better than this.
yeah.
Yeah, let's do that. So here, let's do the limit as x approaches 3. X minus 3 squared over, sorry, let me do that on the top. Over yeah, sorry, I'm really struggling here. Sine x over, sorry, it's too difficult. X minus 3.
Okay. over cosine. The top just becomes 2x, right?
With the derivative,
Yeah.
it's 2 times x minus 3.
Oh yeah, okay, wait. And then the cosine. So in the cosine of x.
Minus 3, because you keep the inside.
Oh, and then if you did a chain rule, it'd be like 1.
Yes,
Okay.
that's correct.
And then you plug in the 3, so that's 2, 3, 0. Zero.
Yes. Because it's 0 over 1, which is 0. Right? Cosine of 0 is 1.
Yeah.
Okay. All right. Now, we can do infinite limits using the same approach.
Is that what we did earlier?
No, you didn't do it in this chapter, but it's part of L'Hopital's rule. Like, we can wait on that.
Okay. Was that what we were doing at first called infinite limits, or was that called something else?
Yes, infinite limits. Yeah, that's what it was. Okay, yeah, I guess we should do this. This is a great multiple choice question. So the question here, it's saying find the value of a that makes this continuous.
I don't remember how to do these at all.
Well, you what did we do in the previous piecewise question?
Plug in 0.
Yes, so I want you to do that for both this one and then this one.
Okay, so 4 sine. And then sine 0 is
This should raise some warning signs here. Like, what's sine of 0 over 0?
undefined.
Undefined. So like in some ways, what we're really asking is the limit as x approaches 0 for sine x over x, and you get 0 over 0, this indeterminate form. So what do we do? What did we just do in this scenario?
Derivative.
Derivative. So for cosine x over 1.
And then it's 4 times 1. Wait, plug in 0. Yeah, 4 times 1 over 1. So 4.
Yes. So this part right here, it always goes to 1, like the end, but it's because of this L'Hopital's rule thing, and then that 4 comes out in front. So this is 4 equals a.
Okay.
All right, so let me see if you got this other version had one like it. Yeah, it's the same thing though.
It's the same question.
Well, I mean, it ends up being the same. Like after you do this one step, like it becomes 3 equals a instead of 4.
Yeah.
So it's not that interesting. Yeah. The other questions on here are maybe okay, maybe we should do yeah, you could get an average rate of change and instantaneous rate of change. So let's do maybe one of these here. All right, so let's do the average rate of change from let's go 1 to 3. An average rate of change is essentially the slope formula. So that's
Okay.
y2 minus y1, x2 minus x1. They dress it up here and they say f of b minus f of a over b minus a. But it's really the slope formula. So you're going to take this ordered pair 1 comma 3 8 and this ordered pair 3 comma 34.2, and you substitute them into the formula there.
Why do you choose those two again?
I have to tell you A and B that you have to be given that.
Oh, I see. Okay. So then it's 34.2 minus 3.8 over 3 minus 1. So
Yes.
I don't know. Something
Yeah.
over 2.
Yes. So it's whatever it is over 2. You'd probably get nicer numbers. Okay. So so that's kind of what this. So when they asked for the instantaneous rate of change at 3, you had a calculator here, but you use like this value and this value, and then you average rate of change, and then you kind of worked them together.
So it's 15.2 feet per, or no, meters per second, right?
Sure. Yeah.
Okay.
Yes. But it's reasonable, I guess, to ask you the average rate of change.
Wait, so if you, why'd you highlight 2 and 4?
Because if you were actually asked this problem, you would need to like find the average rate of change from 2 to 3 and then from 3 to 4 and then use them together.
Oh, if you said if you didn't give the from
Yeah.
1 to
Yeah.
2. Okay.
Yeah. But this is kind of a like maybe one I would ask, because it's not really relevant now that you know how to do the derivatives, but it so I would maybe ask if you'll ask with a table. That's the key here.
Okay.
All right, so I'd like to move to chapter 3, if
Yeah,
you're okay with that. And then there's a quiz and a test there, so I can look at both here. Does your instructor use piecewise functions often?
Yeah. Like all the time.
Yeah. All right. Lots to choose from here. Yeah, let's just start. I guess we'll just start here. So you know how to take derivatives. You're going to be expected to find derivatives on your test here. There's this, and it's kind of all together, but this is the thing you're taking the derivative of here. And when I look at this, I see a product rule followed by another product rule.
Yeah.
Okay, so will you give this one a try on your own, please?
Yep. Does 2x times sine x become 2 sine x squared?
No, nothing goes inside the parentheses.
So when you do product rule, can you write it out to make sure I got it right?
For the first one, it should be x squared cosine x plus 2x sine x simplified.
I just started it like I flipped them because I
Okay.
2x sine x plus cos, yep, okay, got that.
Okay, and then are you ready for the next one? Or?
Yeah,
All right, so the next one is minus x sine x plus cosine x.
yeah.
This is where you gotta be careful with multiple choice, because here is another way the answer could be presented. X squared plus 1 cosine x
Oh, you just leave it like that? Oh, okay, I was like trying to simplify it.
plus x sine x. Well, no, this would be how it would be written in multiple choice, or some variation of that. So like you still want to, and that's how the AP style is. You still want to work it out into this form.
How did you get to that form?
Okay, so let me move this down and then talk to you about it. So you just look for like terms. Okay, so there's a cosine squared on the right and the left here. I'm just trying to get another color to make this clear. That and that.
Mhm.
And there's really like a 1 in front here. So
Yeah.
if you factor out a cosine x from both, it's x squared plus 1 is left over.
Oh, I see. Okay.
And then these you can just straight combine because they both have an x in front of them. There's 2 x's and then there's minus 1x. So that's why it becomes plus 1x sine x.
Oh, okay. Gotcha.
All right. So you have to for sure be able to do a product rule derivative there. So let me give you another one to do to practice here. So let's say I give you y equals x cubed cosine x minus or plus x squared sine x. Let's do this one.
So
And oops, let me remove this. Okay, so it's just a couple of product rules.
I'm just kind of confused how to simplify this.
All right, so let me write out the derivative here. Just try out with this. So it's minus x cubed sine x for the, and then it's plus 3x squared cosine x.
Oh, you just dropped the negative in front, I see. Because isn't it negative sign?
Yeah,
Okay.
it goes. So then we come over here. Derivative sign is cosine, so it's plus x squared cosine x. And then let's see here, and then it's plus 2x sine x. Okay, so this time, let me use different colors here because I think that will be helpful. Sine x and sine x here, but they don't combine because they're different, but you can factor out a sine x from both. And then just as a preference, I'm going to put 2x minus x cubed here. But in truth, you could actually factor out an x out of both. So there's actually a lot of ways that this could be presented. So it could be that the x, so it could be this x sine x 2 minus x squared. That would be another variation. Sorry, go ahead.
Oh, so you're just doing the first one. I see. Okay.
Yeah, now we're going to handle the cosine x here. So it's plus cosine x, and then well, actually, I'm sorry, they both have
Where
x
does
squareds.
where does the 2x minus 3x cubed come from? You took out a sine x and then.
Let me switch back to that color.
Oh, you're doing the first and the last.
Yes. Yes.
Oh, gotcha. Okay. So then in that one, it's
so it's 4x squared because there's 3 of them, and then there's 1 of them here.
okay.
Yeah, I mean, I wouldn't want you to get too caught up on that, but it is important. And it's important to be able to simplify. Like that multiple choice is like a teaser. They're just, the instructor knows that you can make this difficult by giving you multiple choice. It's not any easier in some ways.
Yeah.
But your AP is part of that as well.
Mm-hmm.
Okay. Do you want to give this one a try? Yeah. It's using a quotient rule.
Okay. So can you make it a little bigger?
Yeah, I don't know why this. Oh, there it is.
Thank you. Derivative of the bottom. So it's derivative of the bottom minus derivative of the top over the bottom squared, right?
So it's just bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. Yeah.
Backwards. Okay, so 2x cubed times 2x. Six squared. If it's 2x cubed squared, does that become 4x cubed?
To the sixth. To the sixth.
Okay, so you do multiply those.
Yes.
Okay. So I've gotten 4x to the 4th, right?
Yep.
And then minus 6x to the 4th plus 6x squared over 4x to 6.
Yeah, and you might be feeling good, like, okay, I got it, but really there's more to do here. So you got to combine the like terms. So it's minus 2x to the 4th. But then you're really putting them both over this 6x to the 6th.
6x to the 6th.
I'm sorry, 4. Okay. Sorry, 4. I wrote the wrong thing.
So then it becomes negative 1/2 x. So you do the bottom minus the top, the denominator minus the numerator for the exponents.
I would prefer to see that. I mean, there's a lot of ways to write this. I mean, you could write negative 1/2 1 over x squared plus 3/2 times 1 over
No,
x.
but I'm saying that you subtracted x to the 6th minus x to the 4th.
It's 4 minus 6, but then it's -2.
Yeah.
So you move it down to the bottom to make it positive.
Oh, I see. Okay.
You know, I suppose in some weird scenario you could get that.
And then you just leave it like that because the bottoms, the exponents are different.
Yes, yes.
Okay.
All right, so let's do one more like this. I'll make it a little nicer. Let's say it's 4x minus 1 over 3x plus 1, and I want you to find y prime.
X times 3. You have to FOIL out the bottom.
Nope, you can leave this over 3x plus 1 squared, but the top definitely simplifies.
Squared, then that's is it 7 over 3x plus
Yes.
1 squared?
Yes, yes.
Okay.
We covered a lot of chapter 2. Chapter 3 is kind of your big derivative, like learning how to do derivatives. And then chapter 4 is where you use the derivatives.
Yeah.
So like we could actually go to chapter 4 or 5 or whatever. I guess it's 5. Although 5 was a lot of like min max stuff, but I guess the point is, I guess like everything builds on itself. So we don't have to, we can keep going through this, but like stuff from chapter 5 will like, there'll be a problem with quotient rule in it. So you can practice that if you want.
Yeah, and he said it's not going to be like an order, like unit or anything.
No,
So
it's just a question like that.
yeah.
All right. Well, I guess we got a lesson scheduled for tomorrow. So I will see you then, and I'll
Okay.
send you over the notes shortly.
Thank you.
You're welcome. Have a great night. Bye now.